my name is Michelle Sprake. I'm a Payload Systems Engineer at Airbus Stevenage in the UK. Solar Orbiter is a European Space Agency mission designed to observe our local star, the Sun, close up. It was designed and built in Airbus Stevenage in the UK and was launched in February of this year. Solar Orbiter's mission objectives are to better understand how our local star, the Sun, creates and controls the plasma bubble that surrounds the solar system and ultimately influences the planets within it, including us here on Earth. Solar Orbiter is going to observe the Sun in ways that we have never done before. It features 10 state-of-the-art instrument sensors and cameras that will be able to take high-resolution images of the Sun closer than Europe's ever been able to do before. And it will also be able to sense or taste the particle environment around the spacecraft itself, which will provide a link for how the plasma bubble develops as it moves outwards into the solar system and how it interacts with us here on Earth. Solar Orbiter also has some unique features in that for the first time, we will be able to use the spacecraft to view the solar poles. This is where much of the solar magnetic activity is thought to originate and will be able to help us understand how the Sun creates and controls this plasma bubble. Solar Orbiter, at its closest approach, or perihelion of its orbit, will be able to hover over a region of the Sun for several days, enabling us to view how solar activity evolves over several days in one place on the Sun. Overall, Solar Orbiter is going to give us an unprecedented insight into how our local star, the Sun, works. It will help us better understand the solar cycle and how solar activity can affect us here on Earth. Now, as you can imagine, going very close to the Sun, the spacecraft is going to get hot, far hotter than the cameras and spacecraft electronics are going to like. Therefore, we've had to develop what we call the heat shield, which is attached to the front of the spacecraft to protect the images, sensors and spacecraft electronics behind it from the extreme temperatures it's going to receive getting that close to the Sun. The heat shield is specifically designed to radiate all that heat away from the sensitive parts of the spacecraft. And the top coating of the spacecraft is made out of dried, baked, ground up animal bones, which is a very, very stable material and can withstand those high temperatures it's going to see. Solar Orbiter was launched in February of this year in the United States, and since then has been making its way towards our local star, the Sun. Instrument scientists and mission engineers have been working hard to commission the spacecraft to make sure it's fully functional ahead of its first perihelion, which should be happening in the next few weeks. Solar Orbiter will be at 77 million kilometres away from the Sun for its first perihelion. As the mission continues, Venus swingbys will be used to get the solar orbiting spacecraft closer and closer to the Sun with each orbit. Its closest approach is expected to be 42 million kilometres away from the Sun, or well inside the orbit of Mercury. Solar Orbiter has had an exciting few weeks. Instrument scientists were able to predict that Solar Orbiter would be passing through the tail of a comet, Comet Atlas, in early June. This has never been predicted to happen before, and an encounter with the comet was an opportunity too good to be missed. It turns out that 4 of the instruments on board Solar Orbiter are very able to give interesting data about what the comet tail is made of. And instrument scientists and engineers were able to make sure these instruments could be switched on as the spacecraft passed through the comet's tail. And we should be seeing what information they were able to gather over the next several weeks. Solar Orbiter is now entering its first perihelion, or closest approach to the Sun. And we are all very interested to see what data the spacecraft can bring back to Earth and tell us more about how our star works.